Now that we've focused on system logging, let's turn our attention to the Ldif or LDAP storage format. This is the standard format for presenting information to your LDAP server. It features a standard import-export format which is returned by and supported for import by LDAP related tools, both offline and online tools such as LDAP add, modify, delete, so on and so forth. Even the slapd tools like slapcat produce Ldif formatted files. The Ldif format can be referenced in its full specification via RFC 2849. So if you use RFC editor or just Google RFC 2849, you can read the specs about the format. But the format is very straightforward, and we intend to cover it in this section and show you how it works with various tools. So to get familiar with the format, let's set up some tasks. Our first task will be to execute LDAP search to enumerate the contents of our DIT, as it'll produce an Ldif formatted dump to stand it out. Let's find an area where the server we're connected to, the second server, or we'll run it locally. History grep LDAP search. Nothing's in the history here. Let's try it on this host as the user root. And there we see some instances. These were the recent searches that we performed in the LDAP search section. Let's take a generic search, object class equals star, which searches from the top of the hierarchy and attempt to search against SUSE 2. Now notice we're unable to contact the server, the LDAP server, the primary server. If you recall, we purposely modified in our logging section, we misnamed a directive, the rootdn directive, calling it rootdns, which is why the LDAP server is not running on the primary server. So if we execute this search against, let's say, the secondary server, serve4, if it's running, it'll return. Let's ping C3, like CBT serve4. Doesn't know the host, so let's try it by IP address. And there we see the output. We'll then copy and paste the output into our config file. In fact, we'll just take one object, such as the user Linux CBT1 that we recently added using the LDAP modify tool. In unsaved document, we'll paste and discuss. Now, here's the standard Ldif format. Per line is an attribute, so one attribute per line. Let's take notes. So LDAP search dumps DIT to standard out, and we can analyze it to further infer that the following holds true. One attribute per line, as we see in the case of each of the attributes. In the case of the second line, line number 2, or the first uncommented line, the attribute is distinguished name. Distinguished name references CN, the organizational unit container, as well as the top-level domain container object. Everything on this line pertains to the attribute DN, and this is a standard line in Ldif format. Lines can, however, span two lines. So for example, if you're typing and you've run out of space on a given line, you can move your item to a next line so long as you start the second line with a space or a tab. So in our notes, lines may exceed a single line if the next line begins with space or tab. So as an example, we've extended this particular object to a second line, we'll press space. Now we're going to create a new user. We'll call that user test user, which we'll subsequently remove. Let's label this user test user 1 and have the second portion of the distinguish name attribute run to the second line. Now again, we could use a single space or a tab to send the item to a second line. In the event that we've run out of space, supposing we're using gedit or nano or some sort of editor which wraps us to the next line, as opposed to wrapping or causing the line to span 2 lines without a leading space or tab, include that leading space or tab to be sure that the LDAP tools, administrative online and or offline tools, are able to process the contents of the file, modifying your DIT. Now, in order to specify multiple entries, in other words, multiple attributes, we use separate lines. So it's a reiteration of the first rule, or rule A, and that is multiple attributes are represented on multiple lines. When defining a user, as we will momentarily, we tend to include multiple attributes, as multiple attributes are usually required for a given object class, such as inet.org person. So the second attribute which defines this user test user 1 is the common name. Let's update common name to be test user 1, and that's the second attribute. The third attribute is surname or last name. The fourth attribute is male. The fifth is labeled URI, which is optional. Room number, department number, telephone number, and the all-important object class. Let's just note that every object in the DIT must have at least one object class attribute. It's very important because the object class attribute, as we've mentioned, is a template, functions as a template for the fields or attributes associated with a given object. So in the case of this user, the template fields, or the fields that constitute the user test user 1, derive from the object class inet.org person. So this is why we must specify an object class. It tells LDAP where to get the fields or attributes that constitute the user or the object that you're defining. We say user, but we really mean object. In this case, the object represents a user, but the more proper term is object as opposed to user, because an object can be anything, including a user, but a user is only a user. So again, the simple rules when constructing Ldif files is to ensure that you indicate one attribute per line. But if a given line needs to extend beyond one line, then begin the following line with either a space, a single space, or a single tab. In general, multiple attributes are represented on multiple lines, as we've seen in this document. DN, CN, SN, mail, etc. are all multiple attributes. And when defining an object, every object in the DIT, the directory information tree, must have at least one object class attribute, which defines the template to be used for, and we should note that, which defines the template, which basically equates to schema to be used for the object. In other words, where to find the fields for a given object. Now let's go ahead and try to, as second task, add the test user to the DIT. Now before doing so using LDAP add, we should start the master server. If you recall, we mentioned that the master server is not running because we mislabeled a key directive. That's the root DN directive. We renamed it to root DNS. So let's go to our shell where we are root on the master, and that's not this host. We'll SSH as root to Linux CBT SUSE 2. We're prompted to authenticate, and once on, we'll modify etc open LDAP slapd.conf, and we'll find root DN, where you'll see momentarily that it's been set to root DNS. At least the uncommented root DN is set to root DNS. So we'll update this to the appropriate value and then execute rc ldap start. Now, just a quick note. The LDAP process slapd has no bearing on whether or not slurpd will start. Slurpd was running in spite of the fact that slapd was not. So note, a misconfiguration in slapd or slapd.conf will not, or one which causes slapd to stop will not impact slurpd, which is why slurpd was running in the case where slapd was not. So now slapd is up and running. An echo of the exit status confirms as such, and the netstat ntl grep 389 also confirms as such. NTLP will show that slapd is bound to port TCP 389, as well as for IPv6. We can then construct an LDAP add. Let's check our history to see if we've got one. And we'll borrow one of them which references a file. This one will do the trick. But the file will have a different name. We'll just paste it into shell. In this case, we don't need a file. We'll just use standard in. And then we'll copy this block again, execute it on the shell for the local system. It waits for us on standard in, and then navigate to our Ldif file to try to paste the items in. Let's update the user's email address so that it's distinct. And at the end of it all, we'll Control D, and the new entry was added, despite the fact that the first attribute stretched across 2 lines. Again, this is how you indicate it. A single space or tab will do the trick. Control D once again will kill us, and if we LDAP search, and we miss the prefix L, and this search searched an incorrect organizational unit. So let's search for the OU that we've added to, which is the people OU. There we see, and we have an error, so we see an error. That's exactly what we see. We need a comma. Now we see the items in the OU people. There's test user 1, and we could further drill down, setting the DN, for example, or the CN equal. Let's set CN equals test user, and that's test user 1. And there we see one record for test user 1. Recall from the last section that the search for many of the records which constitute an object is case sensitive, which is why we're able to search lowercase test user 1 and have mixed case test user 1 return. So there is the Ldif entry, which is in our DIT, and it looks exactly how we indicated it on the command line. So the tools that we use to search, add, modify, remove, or delete, etc., slapcat, etc., all import or support the import of Ldif and export using Ldif. It's the common, consistent format across the board. Let's use that same Ldif as a next task to remove the user. So as task B, we'll use LDAP delete. Now we should be able to find LDAP delete in our history, and if not, we'll find it in our notes, but here it is. If you recall, when we delete using LDAP delete, we need to specify the common name of the object, as we see in this example above. Perhaps this is a better example to copy, as it contains an example of a user that we successfully deleted. So we must specify the common name of the user. In this case, the common user is Linux CBT1, or test user 1, that is. Now the purpose of this exercise is to show again, using standard Ldif format, we can add using Ldif format as well as delete using Ldif format. In this case, albeit we're specifying a single attribute, but that single attribute in Ldif format is enough to remove the user. Now this isn't the fully qualified hierarchical LDAP name of the user in the DIT. It's OU equals people, then DC equals Linux CBT, DC equals internal. So let's try to delete the user using this particular Ldif entry to see how it behaves. Now notice we've got, this is the bind, that's why there was an error, so we should fix that. CN equals manager, we updated the wrong field, it's here. That's the bind DN, as opposed to the option on the command line that LDAP delete reads for deleting. So this is standard Ldif form. This will prompt us. We'll echo the exit status. It doesn't give us much indication unless we turn on verbosity or enable logging to the console as we've shown you in the logging section. However, when we rerun LDAP search, we should see that the user no longer exists, which explains why no records were returned. So using standard Ldif form, we can add, delete, and how about modifying? LDAP modify, and again, let's search our history. We know we have it somewhere there. Here are many entries. However, before we modify the test user, we need to re-add the test user to the DIT. So let's find LDAP add in our history to repopulate the DIT. This will paste the item in, Control D, and then we'll confirm using LDAP search that the user indeed exists, and there's a user. Now supposing we wanted to modify using standard Ldif form, we would pick a field that we're interested in. Supposing we wanted to change the user's department number from development to sales. Let's go ahead and find one of our modifies. And we should have in our LDAP directory an item for modification. And in this case we don't, which means it's on the remote server Linux CBT SUSE 2 in the LDAP subdirectory. That's LSL grep modify, and there we have a modify user Ldif. Let's cat the contents to see what's of interest and copy and paste the Ldif syntax from it to our notes. So when modifying, we indicate the distinguished name of the user and the change type, whether modify, add, delete. We then specify the field to operate on and its new value. So we've just decided that we'd like to update the user's department number from development to sales. Let's go ahead and copy this block. And we'll replace department number, making it sales. Now notice from the modify section, when performing multiple modifications, we separate the items, the attributes to be modified using a hyphen. But in this case, if we're replacing only one item, then we don't need the hyphen. Now again, this is standard Ldif form. One attribute per line, and if we need to wrap, we indicate a space or tab, and that's basically all there is to it. The attribute name that you need and its value. So it's really name value pairs, as is the case with standard programming languages like Perl, PHP, Python, etc. Now we can supply this on standard in or supply it as a file to LDAP modify. Here's streak rep, LDAP modify. Returns the various invocations. So perhaps the smart thing to do is create a file. We'll nano here modify testuser.ldif. And we need to modify the user to be cn equals testuser1. Otherwise, we'll end up updating the wrong user. Now let's rerun LDAP modify, or run LDAP modify, instructing it to process the standard file. Again, the DN is cn equals manager, DC equals Linux CBT, DC equals internal, -X for simple authentication, -W to prompt for authentication to the directory, V for verbose, and the file is modify testuser Ldif. Prompts us for the password, and we inadvertently indicated the password, and now it has succeeded. So the entry is modified. Let's rerun LDAP search to confirm as such, which again produces standard Ldif form. Notice the department number has been updated to sales from development. So what does this tell us about the Ldif format? It tells us that it's very simple. If you follow the rules, which are that you indicate one attribute per line, if your lines exceed a single line, start the next line with a space or a tab. Multiple attributes are generally represented on multiple lines, and that every object in your directory information tree must have at least one object class, then you can't go wrong. The Ldif format is very simple. It's basically name-value pairs. So let's just note as a third feature, very similar to name-value pairs from programming/scripting environments. So when operating on your DIT, if you're unfamiliar with the Ldif form, begin with LDAP search. Let's just note that as well. If unfamiliar with Ldif format, begin with LDAP search. The reason is LDAP search, as we've illustrated, dumps Ldif format. This is it. This is the Ldif format, which is basically name-value pairs. The name being the attribute, the value being, or the second half of the pair being the value. Let's just also update our notes to make that clear. Name equals attribute. So i.e. DN, SN, CN, etc. And value is equal, well, value. Such as CN equals manager, or CN equals Linux CBT1, OU equals people, DC equals Linux CBT, DC equals internal. So in this case we have a distinguished name which comprises the full common name plus OU plus DC, which constitutes the distinguished name. So name-value pairs is the format used by Ldif, but the syntax is just a little bit different. We indicate the attribute colon followed by the value, or the name colon followed by the value. So again, the Ldif format is very easy to understand. Any LDAP tool will dump it to either a file or screen for you, or to the screen standard out for you, and from there you should be able to create import files and deal with files that have been exported.